You probably remember the microscope from science class, right? That dusty tool used to look at an onion skin or maybe a pre-made slide. But what if I told you we've all been kind of missing the point? What if that simple instrument is actually a portal to a hidden universe?
I love this quote. It perfectly sums up what we're getting into today. It's not really about the gadget itself. It's about how we choose to use it and the incredible worlds that can open up when we do. Let's dive in. So, let's talk about the problem. It turns out that for a lot of students, this amazing tool of discovery has become, well, little more than just another box to check on a to-do list.
So on one hand, you've got the typical experience, memorizing the names of all the parts, looking at boring dead things on pre-prepared slides, and then taking a test on it. It's a chore. But on the other hand, think about what it could be. A tool for real, hands-on discovery, a window into living, breathing ecosystems where students get to ask and answer their own questions. And, it's not really a surprise this happens when you dig into the official standards. If you search the next generation science standards, which are a huge deal in U.S. science education, for the word microscopy, you get 0 results. Yep, not one. That's a pretty big blind spot, don't you think?
Okay, so that's the problem. But what about the solution? What happens when you totally flip the script? Well, one educator, Joel I. Cohen, designed a course that did exactly that. And it all started by looking for a hidden world in a single drop of water.
And the inspiration for this goes way, way back to the 1600s, to a guy named Antony van Leeuwenhoek. He was one of the very first people to peer through a simple lens and discover this entire bustling world of what he called animalcules, tiny animals. It literally sparked a scientific revolution. And that's the feeling this course tries to bring back, that pure jaw-dropping sense of wonder. So, how did they do it? It's actually brilliantly simple. Forget the boring slides. First, the students create their own ecosystems, little mini ponds right there in a jar. Then, they become explorers. They learn how to hunt for life and document everything they find with photos and videos. The whole game changes from passive looking to active investigating. And you have to see what they found. This image right here? This isn't from some textbook or a stock photo website. A student took this. It's a living cyclops, a tiny crustacean, and look, it's carrying its eggs. They weren't just identifying a species, they were witnessing life happen, right there on the slide.
And then it got even cooler. They found one of these, a tardigrade. You might know them as water bears. These are the microscopic superstars famous for being pretty much indestructible. Can you imagine the excitement of being the kid who finds a real-life tardigrade in your jar of pond water? That's amazing.
But this wasn't just about creature spotting. It went so much deeper. The students were actually watching some of the fundamental processes of life itself come together. This shot shows simple membranes forming from chemicals, which is basically a preview of how the very first cells on Earth might have gotten their start. Mind-blowing stuff.
Okay, this all sounds like a ton of fun, right? I mean, who wouldn't love this? But here's the million-dollar question for any educator out there. Does it actually work? Do the students really learn more?
Right. Is it just fun and games, or is it truly effective education? Well, the proof, as they say, is in the pond water. Let's look at the numbers.
And the results? Wow, they were honestly staggering. Before the course, the average score on a pretest was about 56%. Okay, not bad. But after just 3 weeks of this hands-on exploration, that average skyrocketed to 84%.
Let that sink in for a second. That's a 28 percentage point jump in just 3 weeks. This is the kind of hard data that shows when you let students be explorers instead of just memorizers, they don't just have a better time, they learn a whole lot more.
But the story doesn't end there, because what's really amazing is how this whole project zooms out, from the tiny world inside a jar to some of the biggest global challenges we all face.
For their final project, students had to connect the dots. They had to take everything they observed in their little pond ecosystem and think bigger. How does this relate to the real world, to issues like pollution and the health of our planet?
And this poster right here is a perfect example. It was made by a student, mapping out how pollution would impact the very creatures they'd been studying. This is where it all clicks into place. You go from a tiny organism in a jar to a massive global issue like the ones addressed by the UN's Sustainable Development Goals.
And if you're not familiar with them, the SDGs, the Sustainable Development Goals, are basically the world's to-do list. There are 17 huge goals set by the United Nations to tackle everything from poverty to protecting the planet.
What's so cool is that this one little classroom project hits on so many of these big goals. Obviously, it's a home run for SDG 4, quality education. But by studying what lives in the water, They're learning about SDG 6, clean water. And by seeing a whole ecosystem in miniature, they're getting a hands-on lesson in SDG 15, life on land. It's all connected.
So, let's bring it all home. We started this whole journey by looking at a simple tool that's probably gathering dust in a school closet somewhere. And now we're talking about the future of the entire planet. Pretty wild, right?
This beautiful quote from the legendary biologist Rachel Carson just nails it. It's not enough to just identify something. Real understanding, well, that comes from getting a feel for the whole life of that creature, its entire world.
And really, that's the big takeaway. The microscope is so much more than a tool for looking at cells. It's a lens that helps us understand massive ecosystems and, yeah, even our own place in the grand scheme of things.
So I'll leave you with this final thought. We live in a world that's obsessed with complex, shiny new technology. But maybe, just maybe, some of the most powerful tools we have are the simple ones we've forgotten about. It makes you wonder, doesn't it? What else is hiding in plain sight, just waiting for us to take a second look?